All right. Today we're going to talk about factoring basic trinomials that are in the form of x squared plus bx plus c. All right. So, and before doing that, let's explore. All right. Let's have a practice where we multiply a binomial by binomial. Can we go through that and do that yourself? Maybe you want to pause this and do it yourself, and then come back to and check. All right. So that's what we got, and make sure that you have it the same. All right. Now, this is the trinomial that we have actually got after expanding this the product on top, two brackets on top. All right. So the idea is that we want to go backwards. So you're given the trinomial x squared plus 8x plus 12. Can you write it as a product of two binomials? All right. Now, what you can do is that what you can actually look at some patterns that are showing up. You see this number 6 inside the bracket and a 2, and also be aware of this 8 and 12. These numbers are related to each other. All right. So 6 and 2 and 8, they're related. How do we get 8 out of 6 and 2? Well, this 8 is when you have 6 plus 2 in the bracket, those single numbers that you can see. That's what, when you add them, you get 8. How about the 12? The 12, what happened to the 6 and 2? That was 6 times 2. You got that. Well, that's the pattern that you're going to use every time to factor a polynomial that is factorable. Okay, now let's look at a problem. We have this trinomial x squared plus 11x plus 24. We want to write it in a factor form. That means we're going to write it as product of two binomials like that. All right, to do that, the first thing you got to do, you're going to figure out this number 24. Notice that the 12, that's the multiplication of the two numbers in here. You end up getting the 12, right? So two numbers you multiply, you get 24. But the same two numbers, when you add them, you should get 11. All right. What are the options for 24? So we have 12 and 2. We have 3 and 8. All right. But remember, multiplication, these are multiplying to get 24, but when you add the same two numbers, you must get 11. So this will not, the 12 and 2 will not work, but 3 and 8, that would work. So that would be the two numbers you're going to put in there. So each of the brackets is going to have an x, because we started with x squared. And then the numbers that you add for the second term for each of the bracket will be plus 3 and plus 8. And that's how you do it. The important piece now is you check your answer. Well, you go ahead and do that. So when you expand this again, you should get the original trinomial back. And if you don't, that means you messed up somewhere. So, but in this case, you will get it back. All right. So checking is very, very important. All right. Another example. Let's call that example B. That was example A. Same idea again. This time our trinomial is based on m squared minus 6m plus 9. All right. So same idea again. Both brackets, we're going to open up both two brackets, and each bracket will have an m inside, and then we have to come up with the numbers that we're going to put in each of the brackets. So number 9 right here, the constant term of this trinomial, constant term that doesn't have any variable in front of it. So the two numbers you multiply, you get 9. There are not a lot of options. 3 and 3, that's the very first one. The next one is 9 and 1. But then remember at the same time is that you have to make sure the same two numbers you multiply, when you add them, you should get minus 6. So 3 and 3, we'll get 6 but not minus 6. But if you do minus 3 and minus 3, will get you minus 6. And the same thing with the minus 3 times minus 3, that will give you positive 9. So in this case you will have m minus 3, m minus 3, and in this case you actually have a perfect square trinomial. And the way you write it, because they're the same m minus 3 is showing up twice, you can write it as a compact form of m minus 3 to the power of 2. I want to show you another method. Sometimes some other teachers, they actually use this method, which is fine. It doesn't matter, whichever it works out, that's great. So this method is basically what I call it a grid method. So if you have m squared minus 6m plus 9 and you want to factor that, so to get m squared, you write m and m like that, and basically that's the bottom piece. You're going vertical like this. All right, and then for the 9, their option, now you're going to write down your option. So in this case 3 and 3, but because the middle term is negative, that's negative 3, negative 3. And so when you multiply, so coming down, you're multiplying it like that, right? That's what you're doing. And then so that would be 9 in here and m squared there. So the middle term matters now in there. That middle term is that when you do the crossing, so minus 3m, so that would be minus 3m, and then another minus 3m, so that will give you minus 6m. So therefore, and then the way you write it, you actually rewrite the whole thing as right across like that. So you write it as m minus 3 and then m minus 3. So that's another way of doing it. It's trial and error, but it's called the vertical grid, and some people do that. If you're okay with that, if that makes more sense to you, yeah, absolutely do that. The last thing I need to mention is that this method, so either one of these two methods that we have talked about, doesn't matter the top one or the bottom one, only works, okay, the two numbers you multiply, you get the constant term, and then you add them, you get the middle term. Only works, this method only works when you have the trinomial that looks like and written in this form, and the leading coefficient, which is the number in front of the x squared or m squared, the very first term that is squared, that is 1. And for the most part we don't write it. So let's go back up here. This m squared, the coefficient is 1, so that's why. Here x squared, the coefficient is 1. So this method that we just went through only works when you have x squared plus bx plus c set up with the leading coefficient of 1. That's it.